You canceled, Kyle.
All right, so 5-2.
Trig ratio. Oh, I hate that.
Trig ratios and right triangles. Okay, so when we are talking about trig ratios in right triangles, the first thing we have to discuss is what is a right triangle. And I know a lot of you are probably like, well, this is really, really basic, but I want to make sure we understand what a right triangle looks like. A right triangle. A right triangle always has to have a right angle at its base.
Oh my goodness.
To be a right triangle, it has to have a right angle at its base. And I understand that's not drawn right. Like that's not actually a
That's
right
like an 8 angle.
But so this has to be and by a right angle, I mean a 90-degree angle. Okay? So the base angle has to be a 90-degree angle. All right? And when we're working with right triangles, the side opposite the right angle is always your hypotenuse. And what is a hypotenuse? The longest side. The hypotenuse is the longest side of your triangle. Okay? And we usually call that hypotenuse C. Lowercase c. Okay? Then we usually call the angle uppercase C. So when you're working with triangles, you use capital letters for angles, lowercase letters for sides. Okay? All right? Now, these other two sides, we just call legs. And to be perfectly honest, which one you call A, which one you call B, it doesn't really matter. I usually just go A there and B here, but that's just personal preference. It doesn't really matter. The thing that does matter is how you decide which angle is capital A and which angle is capital B. Reason that matters is if side A is down here, its opposite angle needs to be capital A. So what I mean by that is if the side down at the bottom is capital A, then the angle at the top, or its opposite angle, has to be A as well. You should be able to draw a straight line between your side and your angle with the same letter. Does that make sense? Okay? So then where should angle B be? Right here, right? Okay? Angle B should be able to draw a straight line to side B, which you can, because again, it's a right triangle. Bless you. Okay? Does that make sense? All right? Now, when you're working with these, you are usually going to be deciding an angle that you're going to work with. All right? So you're either going to be working with angle A or angle B to help find your trig ratios. And it does matter which angle you choose, A or B. Okay? So that's where it's an important concept that we understand what theta is. So for instance, if I say angle B is my reference angle, angle B is theta, and I want to figure out my trig ratios from B. Okay? So when you are doing trig, you're always going to have an opposite side, an adjacent side, and your hypotenuse, which most of the time we label these capital O, capital A, capital H. Okay? So if I work from angle B, what side is opposite of angle B? Side B, right? Another way to know how to do it, I put in my tick mark to mark my angle, my little arc here, and I draw two lines in every right triangle I do. I draw from the opposite side, or from the angle to the opposite side, so I know here B is opposite. And I also draw from the corner of the right angle straight out so I know where my hypotenuse is. Now, you don't have to draw either of those. That's just something, when I took geometry in high school, that my teacher showed me, and it really helped me to figure out opposite, adjacent, hypotenuse. So that's why I've just always done it that way. Okay? So then we know this is the opposite side. The hypotenuse is always opposite the right angle. So what's that mean side A is? Adjacent. Okay? Now again, what if I changed my angle of reference from B to A? What changes? Opposite and adjacent just flip, right? Does the hypotenuse ever change? No, hypotenuse is always the hypotenuse. But if I change the reference angle from B to A, well then that changes my opposite side and my adjacent side. They just flip-flop. Okay? Questions on that? Are we good there? Okay? I'm going to teach you an acronym. Most of you probably already know this acronym. SOHCAHTOA.
We can't be having this now.
Okay? So, we are teaching you the three base trig functions: sine, cosine, and tangent. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You good there?
Yeah, I think so.
Okay. Or some people don't like SOHCAHTOA. So again, I go back to my high school geometry class, and our teacher also taught us an acronym. Some old horse came a-hopping through our alley. So, some old horse came a-hopping through our alley. You think that sounds silly or dumb, but I learned that when I was 14 years old, so 16 years ago. And I still remember it to this day. And she taught it to us one time in high school geometry. Why I remember that, I don't know, but I do. But pick whatever way you want. You can come up with your own acronym, mnemonic, whatever you want to do. The big thing you have to remember, is okay, it matters which angle is your reference angle. So this time I'm going to say B is up top. Because again, A and B, it doesn't really matter. So if I wanted to write out the ratio of sine using my side lengths instead of opposite, adjacent, hypotenuse, again, I draw my two arrows. What is my opposite side in that triangle? What is my adjacent side in that triangle? A. What is my hypotenuse in that triangle? So if I want to do sine, SOHCAHTOA, so Opposite over hypotenuse. Well, what is my opposite side? B. What is my hypotenuse? C. So then if I want to know, okay, what is sine of theta of that angle? So it'd really be not sine of theta, it'd be sine of capital B. Because capital B is the angle that I'm working from. It's just taking the side length of B divided by the side length of C. Everybody with me how I got that ratio?
Do you always work from B?
No, you can, it depends. Sometimes it's A, sometimes it's B.
So we'll have a line like with.
Well, it'll either tell you what angle to work from, or it'll let you pick. It may just say find the ratios. And then you just have to define whether it's from A, B, whatever. You will never, ever, ever work from the right angle though. Only the two base angles. Don't ever try and do sine, cosine, and tangent of a right angle. It's not gonna work. Okay? Cosine of B now. What's my ratio for cosine? Cosine is adjacent over hypotenuse. So what is it gonna be? A over C. Good. And then tangent of B? B over A. Good. Now, what if I flip that and said I wanted sine, cosine, and tan of A? Okay, so if we wanted to do sine of A, now opposite would become A, so it would be A over C. Cosine of A would be B over C. Tangent of A would be A over B. So really what happens? Look at those two ratios. What really happens here? What happens with sine and cosine? They just flip-flop, right? So sine and cosine, sine of B is cosine of A. They're the same thing. Cosine of B and sine of A are the same thing. The only place it really changes is tangent, and for that one you just flip-flop fraction. Okay. All right. So, what if I gave us a problem like this?
CB first.
Right. So, to do this, we have to know all three sides, right? Well, when you're working with the right triangle, if you're missing a side, Thyra, what do you use?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared, which is also known as what? Pythagorean theorem. So if you're missing a side in a right triangle, do Pythagorean theorem, find that missing side, and then once you have that missing side, you just do your ratios with SOHCAHTOA. So, if we start this, I want to do A squared plus B squared equals C squared. Do I know what side A is?
No.
No. Do I know B? What is it? 18. Do I know C?
Yes.
33. Okay, if you don't know two sides, you're in trouble and you can't really do much with it. So now, if I square these, I get A squared plus 324 equals 1,089. What do I do next?
Subtract 324 from 189.
Okay. Subtract 324. So A squared is 765. How do I find just A? Take square root. Now, let's see, is it a whole number? Hoping it is. Not a whole number. So if it's not a whole number, what's that mean we have to do?
We have to foil it.
We have to cake.
Cake.
No, no. Okay? If it's not a perfect square, you have to cake it. What goes in? Anything that ends in 5, automatically divides by what? 5. So let's pull out 5. 765 divided by 5. 153. Which I believe divides by 3. It does. 51. Which also divides by 3. 17. 17 is prime.
Yep, it is.
So 5 times 17.
So we have one pair. So A is 3 square root of 17 times 5. 3 square root of 85.
This might be a dumb question, but like the last thing we're doing where we were to start is the plus minus thing.
Yes.
Do we ever have to do that here?
Because you can't have side lengths be negative, you don't have to here. No, if it was solving a whole equation, yes, that would be an exact situation you'd have to plus and minus. But since side lengths can't be negative distances, can't be negative, you don't have to worry about it here. So you got 3 square root 85. Now, I know a lot of you are probably like, well, why can't I just use a decimal? And on a test, I'm probably not. I mean, if you rounded that to 27.66, I'm probably not going to get terribly upset. Now, okay, just a rule of thumb. As you move on into up more and more higher level math, when you're working with radicals, if you can break down a radical, professors in college are going to want you to leave it as a radical. They want you to be able to leave it and break it down to 3 square root 85. They don't just want a decimal approximation. Because 3 square root 85 is the exact answer. That's right every time. Whereas this, we round it. Does that make sense? Now, like I said, if on a quiz or a test you're flying along and you happen to round that and you do all the rest of it right, I'm not going to punish you for that, but just get in the habit of caking when you can. All right, now the question that we actually need to do. Find sine, cosine, and tan of B. This all comes back to SOHCAHTOA. So from B, again, I draw my arrows. What's my opposite side? 18. What's my adjacent side? 3 square root 85. What's my hypotenuse? 33. And again, okay, you may think it's silly, but still to this day, every time I do a trig problem, I write that out. Okay, it's just a good habit to get yourself into so you don't forget the ratios. So what's sine of B in this case? 18 over 33.
Leave it as a fraction.
Leave that as a fraction. You don't. If you can simplify, you need to. So in this case, what can they divide by? They divide by 3, so we've got 6 over 11. If you can simplify, you should. Yes. So 6 over 11 is the final answer there. How about cosine of B?
Cosine is adjacent hypotenuse.
Okay. 3 square root 85 over 33. But again, if you can divide, you should. 3 and 33 both divide by 3. So square root of 85 over 11. And then tangent. Opposite over adjacent. So we get 18 over 3 square root 85. Now we have to simplify that. 18 and 3 both divide by 3. So I get 6 over the square root of 85. But then what's the rule with radicals? Can't be in the bottom. So what do I have to do? Multiply both top and bottom by square root of 85. If I do that, I get 6 square root 85 over 85. And that is your final answer. For sine, cosine, and tangent. Are we good there? Hopefully not terrible so far. Not yet. Oh no, we've got.
Hey Kyle, what about in math? Free time?
Yeah, it's not possible.
Well,
He just wants to see the
All right. Last thing. All right. Last thing. So, when you are doing trig, there's actually 6 trig functions. There are our 3 base ones, sine, cosine, and tan, and then the 3 inverse trig functions, secant, cosecant, and cotangent. Okay, so the first one we're going to talk about is secant. Okay, secant is the inverse of cosine. And what do I mean by inverse? Opposite. So it just flips in this case. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. You just flip it. It's hypotenuse over adjacent. The second one is cosecant. Cosecant goes with sine. Sine is opposite over hypotenuse. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. Lastly, cotangent. Cotangent, obviously the only one left is tangent. It's the inverse of tan. Tan is opposite over adjacent, which then means cotan is adjacent over opposite. Okay? Now, I'm going to be really honest. When I first learned this, I had a hard time remembering which one went with sine and which one went with cosine. So, how I came up with it to help me remember is C goes with S, S goes with C. So, C, cosine, goes with S, secant, and S, sine, goes with C, cosecant. I don't know if that's helpful to you, but that was how I remembered. C went with, they don't go C and C. It's never the same letter. Because when I first learned this, I thought it would make more sense. Cosine and cosecant go together. Because they both start with C. But it's opposite. C goes with S, S goes with C. And the shorthand for the secant of theta. Cosecant, SCSC, and cotan is cot, CO2. Okay? We're gonna stop there for today. We'll finish up 5-2 tomorrow.